All right, got cut off there, so I'm gonna pick up right where we left off. So we said the median is 1.55, and so what we want to do is we want to see, do we feel like the numbers here are close, close enough to say that there's no striking deviations? Well, if you think about it, we're talking about inches, right? Inches of snow. Well, this is just under 1 inch, and this is just barely over 2, and the average is 1.5. So no, we're talking about inches of snow here. That's not a striking deviation. All those numbers, all 12 of them, are well within an acceptable range. So again, there are no striking deviations, right? I'm not going to rewrite the word striking deviations, but there are none, right? So going on to the next example here. Now this one's going to take a little bit of time, and this is where we're going to show you how to do the mean absolute deviation. So make sure you're paying attention here. All right, so a website captures information about each customer's order. The total dollar amount of the last 8 orders are listed in the table below. What is the mean absolute deviation of the data? So the first thing to do in the mean absolute deviation is to find the mean. So we're going to add up all the ones right here. Okay, we're going to add all of these up, and when you do, you're going to then divide them by 8. So we're going to have, let's see, 21 plus 15 plus 22 plus 26 plus 24 plus 21 plus 17 plus 22. Hopefully I didn't miss any of those. And divide by 8 because there's 8 numbers, right? And that gives me, when I do that, it gives me 21. Okay, so that's the mean. Okay, now the next thing we want to do is we want to find the distance of each number from the mean. So basically, here's the way I'm going to do it. I'm going to work it up here. So 21 minus 21 minus 21 minus 21. I'm taking the distance of each number from the mean. Oops, 1. And now here's the other trick. I want the absolute value of that. Okay. In other words, I just want it to be positive. I don't need you to necessarily write absolute value every single time you do this. I just need you to remember that these distances are positive. Okay, we're going to put them out to the side. So, distance of 0, distance of 6, because it's -6, and take absolute value. Distance of 1, distance of 5, distance of 3, distance of 0, distance of 4, and distance of 1. Okay, so each number's distance from the mean. So 0.6153041. Now, the next thing you want to do is find the average of those distances. So we're going to take this, right? We're going to take this. We're going to add them all up. So 0 plus 6 plus 1 plus 5 plus 3 plus 0 plus 4 plus 1 is 20, right? And there were 8 numbers. So come down here. The mean absolute deviation, MAD, right? Because it will drive you mad trying to do this, is 20 divided by 8. And that is going to be 2.5. Now, what does that mean? Okay, absolute deviation is a dollar amount, right? In this case, we're talking about money. And so what it means is that the average distance, the average cost, in other words, each one of these distances here, right? Each one of these distances that we were talking about earlier, they're not the same, right? But what would happen is if we averaged out that distance, right? If we equaled out the distance, it tells you how far apart they are from the data, like from the average of the data set. So in other words, the idea behind mean absolute deviation is this. The closer or the smaller your mean absolute deviation is, the closer your numbers are to each other. Okay? It's a measure of spread. Mean absolute deviation measures how spread out the data is. The more spread out the data is, the bigger mean absolute deviation value you'll get. Okay? Because it means the numbers are more spread out. So the average distance from the mean is $2.50. All right? That's the idea there. So, did we answer the question to that? All it said was find mean absolute deviation, so yes, we did. All right? Moving on to the final example here. A company keeps track of the age at which employees retire. It's considered early retirement if the employee retires before turning 25. I'm going to go ahead and mark that, and I want to remember that because the context of the problem could mean something for us. The age of 11 employees who took early retirement this year is listed in the table below. Were there any striking deviations? And because I did that. So, what I want to do there is, I'm going to do it the same way we did it before. I'm going to use the median to find it. So, I want to list these in order from least to greatest. Right? I'm going to do it vertically just to make, just don't have a ton of room. Right, so least to greatest would be 42, 48, 51, 53, 55, 56, 56 again, 58, 59, 60, and 64. Okay? And then when you calculate those, let's see here. We got 1, 1, 1. There are easier ways to do this, but this is just kind of the visual way to do it. Since there are 11 numbers, we only have 1 in the middle, and it's 56, which means we don't have to do that little average thing where you add them together 5 by 2. The middle one is just your median. So our median is 56. Okay. So the question that we want to ask ourselves is there a number that's, way far away from that? Well, one way we can check that is we can look for the quartiles, right? So how do you find the upper and lower quartile? So here's the lower quartile. I know it's on top, but lower means lower numbers, right? So least greatest kind of thing. So the median of those lower numbers would be here. That's Q1. The median of the upper numbers, you look at the other side, okay? And if there's one median, you actually don't include that in the upper or lower half, right? And so we want the median here, which is 59. That would be Q3, right? So my interquartile range that we talked about before, so IQR, is Q3 minus Q1, which is 59 minus 51, which is 8. So my IQR is 8. So what we're going to look at is there anything that stands out beyond that, right? Is there anything maybe beyond 8 units away from, Q3 or Q1? So if I add 8 to this, if I add 8 to 59, it would be beyond 64. So that's within the range, within a good range. If I do 51 minus 8, I get 43. So just barely, I would say 42 might be considered what they would call an outlier. Okay, an outlier. It doesn't fit within the range. And we'll look at some other ways to calculate outlier too. But the trick here is this. If you're thinking about turning 65 and retiring, right, most of these people are very close to that, with the exception of maybe this one guy who's retiring not just early, but very, very early. So he would be considered a deviation from the data. So 42 is a deviation. Right? So use that for 411. And again, if there's some stuff in here like the box and list reply stuff that you were unsure of, me going over very quickly, don't worry. 412, 413, it's going to be carried over into some other stuff. So we'll get a little deeper into that. We just kind of trying to get our toes wet and get an idea of what's going on here. So yeah, good luck. Ask me if you have any questions.